All right, welcome back to Lag Team and Programming. In the compiler design course, in our previous video, we finished up, or we created some classes to be used for the dungeon, and started working a little bit towards a compiler to build those out. But the thing is, I had to reorganize that a fair amount. So I've actually changed. It's not a tremendous change, but I've relayed out how these work. We now have, and I'll go over the code a little bit. We now have an item type and a node type. The nodes can be dungeons, rooms, items, or a description, though we don't have particularly a description node. And I did that on purpose. We just use a dungeon node to carry around some information inside the compiler. We have a base class called dungeon node, and it contains the basic stuff that everything has, which is an ident, a display name, a description as strings, and of course a node type. And this is so we can get some runtime information. During runtime, we can know what type of node it is, and that helps with the compilation process. And then we have an item node that derives from that. We have a room node, and then finally we have our dungeon. Well, that's a room, and here's the dungeon. And the dungeon doesn't add very much to it right now, but we'll do more with that. Over in the parser, then I finished out how we emit these various nodes from this. So let's take a look at that. What's happening here? So ident list items is a driver of the innards of a list, right? That's surrounded by these brackets. What happens here is when we get an identifier that's part of this, because we've started compiling this, we've gotten this token, and now we're expecting this token. It sees an identifier and it creates a new vector for that, and it pushes the actual identifier onto that. When it sees more, a comma and another identifier, it simply pushes that identifier back into that stack. And in both cases, it's setting it to doing it with $1 or $, setting it equal to, in this case, $1, which is this list items here. Which moves it to this position here and into here. This one says $, equals $2. Remember, we count 1, 2. So this simply passes this list on into ident list. And then ident list is used in various places, like items and exits have an ident list. And it gets passed on there and moved on up to form up one element of something, one of these things, okay? As a list of identifiers to fill those in. The same thing happens with other things. We have the display name here and the text, which is just these strings, depending on whether it's name or text. It collects that by creating a new string. Remember that we have to use, if we use strings inside of our union, they have to be a pointer, because the union here inside the compiler can only handle simple types. And a pointer to anything is a simple type. It's simply a number. It's an address. We can't put a non-pointer complex type in here, because this union then would contain that complex type. It only wants simple types. So I've completed this. Another change that I made to finish this out is down here, our function where we eval the function now returns a tuple that's an int and a pointer to dungeon. So yes, it takes an int and a pointer to dungeon. We check for the file, and we open the file as necessary here. When it's come in, if there's something wrong with opening the file, it returns a -1 and a null pointer, which we can check for in main. I'm not sure I'm exactly checking for that, but we will. And then if everything's fine with the file, It creates a tuple for the return value that's going to contain the result of calling our dungeon parse function, which is our parser generated by this file, this parser.y file. And it's going to pass the dungeon result back. The dungeon result is this up here. It's a static pointer to dungeon, and it's what our compiler finally produces here when it finds a dungeon. So we'll take a look at that section here. An overall dungeon, this is the node that compiles the entire thing. So it sees dungeon and an identifier and an open brace, and then it sees all those dungeon items, rooms, items, whatever goes into the dungeon, and then finally it sees the closing brace that matches this one, and it runs this section of code. And so this, just for convenience, extracts some things so that I was less confused. It gets the ident out, and it creates a dungeon node description that's a null pointer. And then we do a little iteration here on the various nodes we've gotten back, because this piece here, dungeon items, is a list of nodes. And it can be anything, a room or an item. It looks through it, and it looks to find the one that is a node type description, and that's a special setting we give on it to say that this is the description for the dungeon in this case. And so we grab that description and we assign it to there. That way we can use it down here. So if the description's not null, otherwise we're going to emit an error that there's something wrong. And we'll do better error checking later. But for now, this is simple. It's just going to spit out that, hey, there was no description for this dungeon given. But if there is a description, it's going to go ahead and create a dungeon. It's going to pass it into the $$ value, which is the end result of this, and create a new dungeon with an ident. It's going to use that description variable to get the display name and the description and pass it in. That way we don't have to have so many linked objects just for a description. We're just going to pass the display name and description in, and then it's going to loop through again all the items just like it did up here, but in this case it's looking for rooms and items, and it's going to add those rooms and items to the $$, which is our dungeon. This is just a shorthand for that. And then the very last thing it's going to do, if there were no errors, is it's going to set that dungeon result equal to $$, and we're good. And then this function down here will pass that back inside this tuple. And let's take a look at that very quickly. Main. What we do here is we call that dungeon eval with our arg1, and so one of the things I did do was I upgraded this to use C++ 17 because it has this nice tuple pattern matching syntax, which basically says that I know that this tuple contains a dungeon and an integer result, and so these two names here are automatically typed accordingly. This is a pointer to the dungeon, and this is an integer result. And if the result equals 0, which means everything was good, and the dungeon is not a null pointer, right now all I'm doing is displaying what we read in and compiled. So let's make sure it works. Let me go into the build directory here, do a quick make. Okay, well, I just recently did a bit of an upgrade, so let's go rm-rf build. That's something else. Preparing for upcoming lessons, I needed to upgrade Ubuntu. CMake error, flux target, unknown command, flux target. Incomplete errors occurred. Great. So my upgrade has broken something, and I didn't think it would. Missing flex executable. Bison found. Flex, missing flex executable. All right. Okay, apparently during my upgrade process, we lost Flex, but it looks like we still have Bison. I hope everything works now. So while this is doing this little install, I'll explain here. In order to get the next phase of our compiler design working, I needed to upgrade Ubuntu to version 20 to get a particular tool working. And I'm still not 100% sure that tool is working, but hopefully it will be, and we can and with any luck it worked. Okay, well that fixed that problem. So now we go to game, and it's // my dungeon dng, and there it compiled it. So what happened here, we printed out a whole bunch of stuff. So what happened here was the compiler completely compiled our my dungeon script that we put together that tells how to build it. It completely compiled this. It generated all of these different classes and types using this code in here. It generated them all. It had no syntax errors. It got up here. It created a dungeon. It assigned that dungeon to this value here, dungeon result. Our parse function down here, our eval function down here, returned that as part of this tuple. Over here in main, that came out as this tuple, a valid pointer. It was not equal to null, and the result was equal to 0. And it called display on that dungeon with cout. And over here, dungeon.h, that's this function, display. It says that it's a dungeon. It calls the dungeon node display, which displays the basic information about the dungeon. And then it says rooms, and then it loops through all the rooms and calls display on each of those rooms. And each of the rooms, of course, has a display function that displays the room, and rooms display their items and exits. And if we look at this, this is what we've got here. So here's a dungeon. That particular thing has no rooms. This room has an exit to the lobby, the main lobby. It has a knife, a scepter, and then there's exits. It has a torture chamber and a cell block, and that's how we kind of put it together, right? So it's picking all this information up and building up these scripts just like it is supposed to do. So we have that, and the next goal will be to connect that into our command line system so we can send commands to these, and we'll probably have to add some helper functions to these to do different things. But if we go over here to our command line language, so this is where we created our commands, and here in main, this is where we run our command line loop. We can pass this in now. So what I want to do here is go ahead and pass this dungeon pointer instead of printing all this out, which we don't want to do. Once we compile, oops. What I actually want to do is call command line and pass it that dungeon. So what we can do here, and then we've got some ways that we can pass that into this eval command. Whenever we pass it in, we can pass in a reference to that dungeon. So it's going to be a pointer. And so what we're going to do here is go dungeon pointer dungeon for one thing. So that's going to be for the command line. And where are we going to call that? Right, an eval command will take a line and also a pointer to a dungeon, so we'll want to do that here. We'll pass in dungeon, but actually then we have to go to eval command, which is part of our command line parser. It's down here. So this also has to have include dungeon.h. So it's got access to those, and then down here on our this, we're going to say dungeon pointer dungeon. And now whenever we access, whenever we execute a command, we've got a pointer to a dungeon. In the eval, so we go back to main. This should be okay now. Oh, we're doing this as an extern, I believe. Command lex, command parse. There's that one. Eval, yeah, we have to have here dungeon pointer dungeon. Oops. This is calling eval command. Where did I put that? I just put that as eval. Here's eval command. We need to pass this on here. And then, oh, we still needed an eval because we got to pass. We're going to call eval here. We need it here. We need to pass this dungeon in. And then we need to pass dungeon into here. Too many commas. Eval command dungeon, eval parse.y. That's getting the dungeon. So now we've got a dungeon we can act upon, but we need to give that access to this stuff where the commands are actually executed, where commands are parsed, and then, well, actually, so that produces those. Pushback, literal. How are we firing off commands in this? Oh, tquit. Nodes.pushback new tquit. Result dot add nodes. Nodes. So that's copying all those nodes, deleting the buffer, and returning the result. Back here in main is where we're executing those nodes. So actually what we want to do probably is be able to pass those into those nodes when we call execute. Oh, we want to put it in the context is what we want to do. That's right. We want to make that part of the context. So maybe we don't have to pass this all the way along. Well, I'll leave that for now. I think we might want to, when we're compiling a command, have access. That's right. We want to have access to the dungeon because we want to check. I suppose the nodes can do that. Let's make sure this still compiles. No, it doesn't. Oh, yeah, because I didn't comment it all out. Okay. That's a warning. Oh. Yeah, we really should return something from this, even though this, we'll just say return 0. This just gets called in a loop. I don't know why I made it an int. Are we doing a... Oh, while context is running, goodbye, return 0. Okay, good. but it compiled anyway, so let's make sure. Yeah, so it compiles, and I'm pretty sure it still runs, but we're not printing anything out now because what we want to do is put ourselves, after we load the game, after we load the game description, what we want to do is call this command line with our dungeon. So what we can do is call command line. And actually, that's what we want to do here. Let's do this. But instead of display result, we want to call command line with our dungeon pointer, else there were errors, game not game exiting. Now we can test that out. We can stick an error in one of these. We'll grab what I do with it. It's right here. Pull it over here. Hopefully this will load it and drop us into our command line, which it has right here. I suppose this might be a little easier to see in the other console. If we quit, which is the only command it knows right now, I think if we put some garbage in here and try to load it, we should get an error. A syntax error, unexpected ident, there were errors, game exiting, so that's good. So our compiler is doing its job. And yeah, so we're all set up to move on to the next section, which is going to be to start building a real language. So in the next few videos, what we're going to do is start laying out how we want a language that we can create some executable code inside our game. There's a variety of ways that we can do that. I want it to be a fairly simple and intuitive language. It's not going to have a lot of keywords or a lot of capabilities. We'll see how far we can go with it. We should be able to make some decent little language that would allow us to control what's going on in the game at runtime, allowing. And if it were a multiplayer game, then there would of course be administrative rights, and only perhaps administrators could put code into the game where players could not, or perhaps players could only put code in that affects their own client or their own situation in some way. We can put restrictions on it and stuff. But for now, we're going to keep it very simple. We're going to keep the game very simple. It's just going to be a single-player game. Well, multi-threaded and networking games is the subject of another entire lesson, another entire course. So I really don't want to get into that in this. I want to focus on compilers and how they work. So I think that's it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I'll see you in the next video. Thanks for watching.